So, brief review of transformations of quadratic functions. So, I find it useful really to use a quadratic that is not symmetrical around the y-axis if you're looking at transformations, to help you understand this. If you use x squared as the base function, you're going to find the horizontal and vertical compressions a little bit confusing. So here I've used x minus 3 squared, and if you factor that out, x squared minus 6x plus 9, so you can see quite clearly that it's got a y-intercept of 9. You should know that this is going to have roots or zeros of 3. It's a repeated root, so it's just going to touch the x-axis. Let's look at the difference between some transformations of this quadratic. What's the difference between minus f of x as opposed to f of minus x? Or what's the difference between f of 2x as opposed to 2 of ff? What's the difference between f of x plus 4 when the x plus 4 is within the function, and x plus 4, f of x plus 4 when 4 is outside the function? So there's our base function, x minus 3 squared, repeated root of 3, goes through the y-intercept at 9. So some simple transformations first. Minus f of x is basically applying a minus sign to all the output results after they've gone through the function. So that's just basically making all the y results negative. So you get a quadratic that just gets flipped upside down, if you like. So you've got a reflection this way from up here down here. Alright, that's a little different to f of minus x. Is different in that it's essentially a right-left reflection. So it's like this quadratic here just got flipped this way. So it's gone from right to left. And it's got the same y-intercept, but you can see the roots. The zeros got flipped around there to minus 3. Alright, so those two different functions when minus f of x is applied as opposed to f of minus x. So just to recap,